All right, on this edition of Sudoku After Dark, where we're just gonna relax, got dark mode turned on, we're gonna just solve a Sudoku. We've got another from the GAS series, the Genuinely Approachable Sudoku series. I just picked a random one. This was from July, I believe. This one's by Philip Newman called Triforce, and it's just normal little killer Sudoku. So if you're familiar with little killers, link in the description if you want to go try this out yourself. The rules are normal Sudoku rules, so we have the digits 1 to 9 in every row and column, and 3 by 3 box without any repeats. And then these little killers are the arrows outside the grid, and essentially the digits along an indicated diagonal sum to the number on the arrow. So these 6 digits will sum to 12. These 2 will sum to 9. These 4 will sum to 18. And digits are allowed to repeat along those diagonals. And that's it. Pretty simple rule set today. So, like I said, link in the description if you want to try it yourself. I'm going to give it a try now. And let's see, we've got this interesting symmetrical kind of almost a tilted square pattern here. It's not quite a square. You can't actually draw a straight line from the middle of the 7 to the middle of the 9 to the middle of the 3. It's going to be a little bit bent, but it's squarish. I appreciate that. And the clues are nice and symmetrical as well. Not that they necessarily need to be. It's kind of interesting that we have the 18 at the bottom here and at the top that are pointing at the same diagonal as are the ones along the other diagonal for the 30. So we kind of have some superfluous or redundant clues. They're redundant and repetitive, and they repeat themselves. But that's okay. I'm gonna look at the 6th clue here because digits are allowed to repeat on the diagonals. However, these 3 are all in the same box, so they actually can't repeat. So I know that 6 and 3 can only be made one way. It has to be 1, 2, and 3. And we know this one's not a 2. So that's a start. We've got 9 in 2 different ways. Oh, we've also got, I didn't even notice. So the symmetrical nature continues, actually. We have the 6 and the 6. We have the 9 and the 9. We have the 18 and and the 21. It's not quite the same. But that's very interesting that many of the clues are the same symmetrically. So we can also do 1, 2, and 3 down here. Now, obviously, with the given numbers in the grid, that's going to mean that the solution isn't going to be symmetric, even though the clues are symmetric. But we do have 1, 2, 3, 4, 5, 6, 7, 8, and 9 given in the grid, which is kind of fun too. All right, so we've got the 1, 2, 3, the 1, 2, 3. 9 can be done quite a few ways. 1, 8, 2, 7, 3, 6, 4, 5. Some like the 2 can't be there, but the 2 could be here. 4 can't be here, but it could be there. So, not sure how helpful some of that is yet. Do we want to do the 18 or the 30 maybe? 21 might be limited. Let's see. We've got 3. So these 3 have to equal 18. These 2 are maximum of 9, or maximum of 8, sorry, because there's already a 9 there. That'd be 16. But this could be as small as 2, and if this was bigger, then yeah, that's not super helpful. This is similar. We got the 2 from 18. These 3 are 16, but lots of possibilities. So I'm thinking the 18 and the 30 might be the way to go. Let's try 18 first. So we've already got the 1. So these 8 cells need to sum to 17. Well, 17 divided by 8 is less than 2. So yeah, the minimum we can put in a box of 3 cells is 6, right? 1, 2, and 3. If we do that twice, we're going to have 12 plus the 1 is 13. So if we're doing the minimum plus 3 is 16. So let's just, oh, actually, that's not true. Because, okay, let's do this the right way. Let's put these in. 1, 2, 3, 1, 2, 3. We have 6, and 6 is 12, and 1 is 13. But actually, the minimum these can be is not 3, because we already have the 1 in the box. So these are 2, 3 minimum, which is 5. 6, 6, and 6 is 18. Those must be those minimums. This is not 2. This is not 3. This is not 3. Look at that. 3 gives us the 2. And the 3, the 2 would also do that for us. So we've got a 1, 3 pair. We've got a 1, 2 pair. Now let's look at the 30. Maybe we can do something the other way. Maybe we need to, well, let's think of it this way. Instead of the total number of cells, let's think of the fact that we have 3 boxes of 3 cells each, right? 3 sets of 3 that are each in their own box. So each of those sets is going to need to average 10 to get to 30. That's less helpful because the max you can get out of 3, well, we do have the 1, 2, 3s here, but still, you do 3, 9, 8, you're at 20. So that one's not going to be as limited. So maybe we could think about the 18 and the 21 again now potentially. Or maybe we should look at the 12. Maybe the 12 is the place to look. So we've got 6 digits that have to equal 12. Again, average of 2. So we've already got 3. So these 5 need to equal 9. If we do the minimums, yep, 1, 2, 1, 2, 3. That, and the 1 there will give us 2 and 1. That 2 means these are not 2. The 1 means these are not 1. The other 12 is going to be the same way. It's going to have to be 1, 2, 3 twice. So these are 1 and 3. We have the 1 down there. So we get 3 and 1. These are 1, 2, and 3. This one's not 3. This one's not 2. And that one's not 1. We now have all of these 1, 2, 3 triples. In fact, we have the 1, 2, and 3 in every box. Let's see, these are not 1. These are not 3. This is not 1. This is not 2. This is not 3. This one's not 1. Okay. 3. Yeah. Okay. And so now we can look at the 21 and the 18 because we've limited 2 of the cells quite well. 1's given to us, right? And 1 is pretty limited. So the 3 here, the most this can be is 3. That would be 6 from 21 is 15, which would mean these are 6, 7, 8, and 9 at least, because 15 requires at least a 6. 6, 9, 7, 8. If this is a 1, then we have 4, and it would be 17, which would have to be 9 and 8. This is obviously not 9. So these are either 15 or 17, which is either 8, 9, 6, 9, or 7, 8. This now, the 9, right, the 9s, both of them. We now have 1, 2, and 3 pencil marked in the box. So the 9 can't contain a 1, 2, or 3. So the only way to make 9 without using a 1, 2, or 3 is 4 and 5. So maybe we look up here at the 18. So these could be, I mean, it's either 3 or 4 together. So these need to be 14 or 15. And you can't do a 4 or a 5. So these are also 6, 7, 8, or 9. This one's not an 8. 14 would have to be 6, 8. But again, 15 could be 6, 9 or 7, 8. Okay. So where do we look now? We've done the 18, we've done the 21, we've done the 12, we've done the 6, done the 18, the 9, the 18, the 12, the 6. So it's just the 30 and Sudoku at this point, I believe. Let's see, we know... What do we know? We know these have to average about 10. And we've got like 1, 2, or 3. So the remaining 2 need to average about 8-ish, right? 8 or 9. But there's a lot of ways to do that, so I don't know how helpful that is. Oh, the 5 right here. Look at this. There's a 4 up there, and there's a 5 here. 4 and 5, 5 and 4. Very nice. Okay. So let's see, the 5s here give us 5s on the diagonal, which is interesting. 5 down here is up there, so it's not necessarily on the diagonal. Putting it on the diagonal now, the 4, however, is on the... I'm going to get rid of the 5 right now. The 4 is on the diagonal, so that gives us some more numbers for our diagonal, which is kind of interesting. What does that tell me? Does it tell me anything? So I know the 4 and the 5. So, I mean, I've got 4 and 5 and 1. That's 10. I need 20 more. I've got, you know, between 2 and 5 here. So I need 15 to 18 from my other 4 digits. Now, it's not necessarily that. It's one of these 2 up here. I'm just going to click that one for now. So 4 needs to be 18. What did I say? 15 to 18? That still leaves a lot of possibilities. So I'm not quite sure yet. This is interesting. I'm not sure. I'm probably missing something obvious. People are probably yelling at the screen, but, you know, that's okay. I can't hear you, so it doesn't really matter. What do we want to do next with this? We know 15 or 17. Is it the 30? I feel like the 30 is the only thing we haven't used yet. Other than some normal Sudoku. I mean, there's a 4 down here. We know that. And there's a 5 up here. But... 4, 6, 8, yeah. Yeah, I think we gotta do something with the 30. Okay, well, I mean, let's just I guess think about the minimums for a minute, right? Just for fun. So these could be 4 and 5 with 1. That's 10. Oh, right. There we go. That's what it is. So because we've already done the 1, 2, and 3 in each box, the minimum we can put in the extras is 4 and 5. If you do 4 and 5 in a box plus the 1 as the minimum, that's 10. 3 times 10 is 30. So these are indeed the minimums, and the 4 there gives us the order of those. And this has to be the 1 and the 3 and the 2. These are going to be 4 and 5, the 4 there, gives us the order. These are 4 and 5, and the 5s up above are going to give us the order of those, and 1 and 2 and 3. And now we can use, if I can type correctly, we can use those to get us the rest of the 1, 2, and 3s. 3, 2, 1, 3, 2, 1. So we get all the 1s and 3s. And now these are 6, which means this has to be 15. These are 4, which means this has to be 14. Now, there's a couple ways to make 14. You can do 9 and 5, or you can do 6 and 8. We cannot do 7 and 7, however, so it has to be 8 and 6. These are 7 and 9. We don't know which one is which yet. I'm just going to get rid of those pencil marks because we know that's 7 and 9. Down here, these are 15, and so it could be 6, 9, or 7, 8. We'll get to that eventually. So now, I mean, I think it's just I think we've done all the diagonals, all the little killers, and we're just down to normal Sudoku. We can do 5s. We have the 5s here and the 5s there, giving us a 5. 5. There's a 5 here, that 5, and oh, there we go. That's helpful. Okay, so do we have, yes, we have all of the 5s. I believe we have all the 1s, all of the 2s, all of the 3s. By the way, I'm just double clicking on one of the numbers and it highlights all the same ones. Okay, we don't have all of the 4s yet. There's one there, there's one there. And then the final one is down here, so that's all the 4s. We've got all the 1s, 2s, 3s, 4s, and 5s. We just have to do the 6, 7, 8, and 9. These are 6 and 8, and the 6 there will give us the order. This is no longer 8. These are 8 and 9, and the 8 there will give us the order of those. So now this can't be 8. Therefore, you can't do 7 and 8 as a combination. This has to be 6 and 9 with the 7. This is going to be the 6. These are 7 and 8. Don't know the order yet. Across here, we have 7 and 9. 7 and 9. Don't know the order of those yet. Down here is 7 and 9. That 7 will give us the 9 and the 7 and the 9. This is 7 because the 7 there. These are 6 and 8. Don't know the order yet. These are also 6 and 8, and the 6 there give us the order. Up here we need 7 and 9. That 7 tells us it's 9 and 7, and 9 for the box, and 7 for the column. We are missing a 6 in the row. We're missing a 7 in that row. These are still 6 and 8, and we have the 6 now, so we get 8 and 6. Missing a 9 for the column. 8 and 9 for this row and box. 9 there tells us the order. At the top for the column, we're missing a 6. This row is missing an 8. The box is missing a 7. The row is missing an 8. And our final digit in the puzzle is going to be the last 7. There we go. All right, that should be the solution to Triforce by Philip Newman. Very interesting little killer. I don't know why I waited so long to figure out the 30 diagonal. I was just wandering around the puzzle, looking at everything and just observing and enjoying my walk through the puzzle, and I just failed to, it seemed like 10 and 3 has many ways that you can do 10 and 3. And I just failed to notice that, the fact that, I mean, obviously I knew we'd already used the 1, 2, and 3, but the fact that 4 and 5 were the minimum with the 1 would be 10. And it would be the case on all 3 of them. I should have seen that earlier, but there you go. A very nice symmetrical puzzle, a very good, gas level little killer. So if you tried this puzzle out yourself, Let me know how it went for you. Did you find it to be gas level and easier, or did you struggle with it? How long did it take you to see the 30 diagonal like me? And of course, be sure to subscribe for more.